Yeah, ladies and gentlemen, I'm glad to be here. Thank you for the invitation. And I've been asked to introduce our experience on the topic. I don't know how popular this topic is here. At least mining seems to be on agenda today. But this has been quite public process in Finland for 10 years. And I will briefly go through this and tell you where we are now and what kind of challenges have been faced. So I will go some basic facts about our companies, something about the mine itself, mineral resources and the production, and then the main topic about the development and sustainability part of it, and then something about the financing. And yeah, I will stick with English, probably better not to start talking in Finnish or some weird combination of Estonian and Finnish. So I'm representing company in the middle, Terrafame Group. We're basically a parent company of the Terrafame, which is operative mining company located in Sotkamo, somewhere in the middle of Finland. Terrafame is responsible on the mining operation as well as any actions regarding the product delivery and so on. We possess most of the shares of Terrafame, so we are the biggest owner. International metal trader Trafigura holds somewhat 16% of the shares. And our aim job is, of course, steer and control them and also take care of the ownership and financial arrangements. And then we have also a technology group where we have projects which, of course, are related to long-term development of the process. And I am head of that group. We are owned fully by government of Finland and are steered by the Ministry of Economic Affairs and Employment. And of course, we are reporting to the government. I could use all the time to present the history of the case, but I briefly go through this. The mineral findings were located in the late 70s, and then Outokumpu started to study the area and develop the technology to utilize the minerals in 80s, and continued it for 20 years. And in 2004, Talvivaara acquired the mining rights and started to put together the mine with the financing, piloting and so on. And they started the production so that down there you see that the first products were delivered in 2009. Talvivaara faced a lot of challenges. Probably the most popular one is a case in 2012 when there was a quite significant leak in the gypsum pond. And all those challenges led to the bankruptcy of the company. And then 2 years ago, we took over the exercise, and we've been ramping up the process after that for 2 years, and now the production has exceeded Talvivaara's production earlier. And why government took over the exercise? The target one was to secure the environmental safety. There were a lot of concerns related to the huge amounts of water at the mining area, and it was seen that the best way to tackle those is to ramp up the production to avoid the freezing of the heaps and so on. Our second target was to within 2 years to prove that the process is economically feasible and it is possible to produce the metals with that process. And the third target was to find public-private financing for the mine. And say that target 1 and 3 are more or less covered. Target 2, it's still in the ramping up phase, but I will see some of the financial figures in the end. This is just briefly where we are now. During first half of this year, we produced 10,000 tons of nickel and 21,000 tons of zinc. Those are the main products. Net sales was around 90 million. We have 7,500 people working at the mining site for Terrafame. There are subcontractors as well. And we're mining 18 million tons of ore annually. And this leads to strategic initiatives. Those are, of course, mine with the target I just mentioned. Then after the mine is ored, we need to extract the metals. The target is, of course, the maximum yield. The business plan relies on yield of 70%. Then we need to extract the metals and at this phase increase the production. And of course always take care of the production efficiency issues. This is the metals recovery plant in the front of the figure, and those are the clarifiers. Heaps are shown on the back. I will now tell about the mineral resources and production. So we are one of the largest known nickel sulfide deposits in Europe, and the main, we're now producing zinc, nickel, and cobalt. Copper production is about to start this year, and there are a lot of other metals available in the process solution. But those will be introduced later after the ramping up is finished. Of course, the uranium plant is almost finished, and there are capabilities to start recover that as well. There are 2 known ore bodies. Currently, we are operating at Kuusilampi. And together, this Kuusilampi and Kolmisoppi means that the lifetime of the mine is several decades. And there is also a lot of exploration potential nearby. So at least in terms of the mineral resources, there's a long future ahead of this site. The production process looks like this. I cannot go into details of that, but in principle, it's an open pit mining followed by crushing, and then the crushed ore is agglomerated with the process solution and stacked into the heaps. The primary heap area is 800 meters times 2.4 kilometers, so it's quite large area for the primary production. The heaps are the metals are dissolved by feeding the leach solution on top of the heaps. The solution goes through the heaps and it's collected from the bottom and then recycled back to the top. Part of this flow is taken to the metals recovery, where we recover first copper, then zinc, and finally nickel and cobalt together. The rest of the solution is either recycled back to the heaps or then taken to the water purification plant, which I will show later. Map of the mine looks like this. Not going into details of that. You need to come there and see it. The whole exercise is based on bioleaching. This is, of course, quite known method globally, but it has never been utilized in such conditions and for the type of ore we are dealing with. It's based on addition of air, so we have aerobic bacteria working there and specific conditions which are controlled by using sulfuric acid to adjust the pH. This process generates the heat and same time the or the metals are dissolved and are as a sulfides in the process solution. And I guess this was one of the topics for you today, as little as I understood in the morning, but at least the greenhouse gas emissions seem to be a topic here. And with this type of process, our greenhouse gas emissions are almost 40% lower compared to typical nickel mine. And there are several reasons for that, but one is, of course, that we are lacking this high temperature smelter process as we leach the metals as sulfates into the solution and recover it chemically. And on the other hand, for instance, the heap leaching doesn't require crushing into small particles. Our agglomerate particles are average size is somewhere diameter 1 centimeter, so quite big particles still. Product is the same with all the processes, and it ends up into steel production of metal alloys and batteries. And especially the nickel industry is changing due to the heavily increasing need for batteries for electric cars and so on. So there's an huge expected growth in nickel consumption. Then some of the challenges and also opportunities regarding the specific features of the process. So first of all, we are located somewhat less than 1,000 kilometers north from here, but the area has been under quite heavy rainfall. This left map shows that the annual rainfall in 2015 was almost 1 meter, which means that nearly 10 million cubic meters of additional water was added to the water balance of the process. Total mining area is 60 square kilometers, and I have now put in your map of Tallinn parallel in the same scale with the map of the mining area, and as you can see, this would more or less cover the whole city if we put it here. Fortunately, we have space there in the north. Other specific feature is the environment. The mean temperature is just slightly above 0, and we are operating in open air, a lot of water, long distances, and then of course the melting of snow in the springtime. Within 2 weeks, 1 meter of snow melts and is added to the water balance. And that's why we have quite extensive water treatment system there. Itself, the production already treats the water, so it takes the metals out from the water. So it basically purified it. Then we have precipitation for the other metals that are not sold as products, which works with the lime treatment, which is more or less the best available technique recognized nowadays. We have opened the centralized water treatment plant in the beginning of this year. It also operates with the same principle, lime precipitation. Then we have a biggest reverse osmosis plant in Finland, which means that we are able to produce water of drinking quality from the process water. This, of course, is then used again for the pure water needs at the site. But we have now 4 ROs and 1 nanofiltration plant, each with a capacity of roughly 150 cubic meters per hour. So a lot of clean water is produced. Sulfate has been a topic in the publicity as well. We have basically 2 ways to deal with the sulfate. One is to precipitate the sulfate to the heaps, and this is what we do with the retentate from the RO plant. Last year, more than 5,000 tons of sulfate was precipitated to the leaching heaps. Then we have also environmental permit. We can discharge 16.3 thousand tons of sulfate annually, mostly through the discharge to the bigger lake nearby. This year, the third quarter is about to end, and we have now spent half of this year's quota. So in terms of the environmental permit and how the process operates, we are safe with the existing permits regarding the sulfate. And regarding all the other metals, all the other elements and metals on the right here you can see that we're way below the limits we have been given. But for instance, for sulfate, the limits now is 4,000 ppms. We are around 2,000, and when that decreases to 2,000, we are quite on the limit. Of course, the heavy rainfall helps to dilute the sulfate, but still. What has been issue and where we also went public 2 years ago was the amount of water and amount of sulfate. On the left you see the history of the excess water or stored water amount at the mining site. It was almost 11 million cubic meters 2 years ago. And of course all the ponds were more or less full, and the production wouldn't take much more hits. But fortunately the production started to work as planned and as it should be, and the water level has come down quite significantly and quite rapidly. Now we are on a target level which is below 3 million cubic meters, and this means that the excess water is not a problem now. And if the production works as it has worked, functioned, this means that this shouldn't be a problem in the future either. And of course we are monitoring the ecological situation of the lakes nearby, and this is all public information, and the lakes nearby are in a good situation, and there are basically no changes have been noticed during the operation under our surveillance. Then to the opportunities. Our specialty is the low grade ore, so the metal contents are really low, and this leads to that we have a process solution with a lot of different elements, but in low concentration. And there are several components which would be economically feasible to recover. Now the uranium is of course the most obvious, as we have almost completed uranium plant. Now we also have it's in our existing environmental permit to recover it, and it's also included in the one prepared this year. Only the permit from the Finnish government and Euratom is missing, so this is basically a political decision to start it or not. But production can be started in 2019. There are also similar elements as uranium, meaning rare earth elements such as scandium, yttrium, dysprosium. Those are categorized as strategic elements within EU, which means that they are basically produced in China and would be safe to produce those also within EU, and this is a site where those have already been processed and dissolved. It's only about the recovery of them. The biggest compound in concentration is iron. Of course, iron is difficult because the value is quite low. There are also significant amounts of aluminium, manganese, magnesium, graphite. So the list is more or less endless what you can take out. It's also only the matter of what is economically feasible. Sulfate was the issue. We came into public 2 years ago, and I started to direct this project in 2015. So as we saw, there were a lot of sulfate and a lot of water, and we had no idea whether we are able to manage with that or not. That's why we started to seek for the solutions. And I was also contacted from Estonia. Few companies contacted me, and I still get a lot of contacts on this issue. This isn't that crucial anymore, but the project has been ongoing. We tested in a small scale some of the ideas. We went to piloting, which finished in the spring this year. And now we are preparing the pre-feasibility report out of that. And based on this report, we will start some sort of a demonstration phase. We will publish something out from this within a few months to reveal the technologies we have developed during these 2 years, and also tell how this will be taken forward. And in long term, as someone here said, that energy is not opposite to some sort of environmental issues. We have also scientific economic upside potential at this mine, but that doesn't mean that it would harm the environment. It's actually quite opposite. Whatever wastes we have, that waste consists of the metals as it's listed. So by recovering those, we reduce the waste. Also, if we start to close the water loops, it will, of course, the water always contains heat. It will recover it. It always contains some elements. It will again recover also that, and of course, it will decrease the need for purification of fresh water and need of purification of wastewater. So there's a potential to, of course, to introduce new products, but also improve the production efficiency, mostly due to building of different type of fluid loops. So there's an advantages to decrease cost and improve yield. Of course, the whole technology is quite new, so in that way, there's also a possibility to develop that and improve the leaching performance itself. Just briefly, some financing. So net sales is increasing heavily as we are ramping up. Next numbers will come next week. Our earnings has positive trend. We are already cash positive, and if we exclude the change in work in progress, this should turn positive next year as well. Because of the type of process and how it proceeds, we are heavily also investing all the time. Now the investments are taking into the secondary leaching, as well as putting the copper into the markets, but tens of millions per quarter, basically. And this all has a huge effect on the region where the mine is, and on Finland as well. We have paid taxes for 140 million. We are employing directly or indirectly more than 4,000 people. This mine basically triples the value of exports of the area there, and of course it also have effect to the turnover of the whole country. So I basically made it in time anyway, so thank you for your attention.
Thank you, Jani. I will not let you get away right now. I do hope that there will be questions from the audience, And actually, I liked very much your last slide. You know, I remember very well once one governmental official was interviewed here in Estonia, and the reporter asked, "Do you know from where you are having your salary?" And he said that, yes, from the state bank. So, but your slide was showing something more essential.
Yeah,
let's say so.
where the money comes to the state bank.
Exactly. Yeah. Good. So, you know, I told you that Estonians are very shy. It takes sometimes time.
Yeah,
They start to move, but I will use my opportunities, and then that was the story of your company now. Very well actually it describes how you have been able to manage problems from the historical background, and how you have renewed all your processes according to nowadays needs. And I guess as all the mining and your processing related issues are under quite a big public interest, that how have you been able to manage relations with the public through all these difficult years as well?
Yeah, that's a bit of complex question, but yeah, of course, as we are owned by the government, we keep contacts to the ministry and to the parliament and so on, and they then communicate further to the voters and the people. But then one aspect you already saw is that we measured, for instance, the qualities of the water that is discharged. That's an open information. One can see that what is the effect of the mine to the local areas. We then, of course, we tell what we have done, what we have achieved, and what are the biggest challenges now. That's like 4 times a year, but also when something happens. Luckily, nothing unexpected have happened. But for instance, if there's a new environmental permitting process, we tell about that. And also locally, of course, always when we tell that we would like to introduce something new, they are concerned that how this will affect. Then we need to organize a meeting and everyone can ask, and then we explain. But yeah, most of the people are reasonable, and it's easy to discuss, even though we might disagree. But there's also a lot of emotions related to this, as it's a quite big and public exercise. So it's a everyday life to deal with the people and with the press and with the political side as well.
Right. And I noticed on one of your first slides that also state as an owner has taken a challenge to support your surviving process. So politicians didn't hesitate after this what happened in Outokumpu.
Yeah, this was basically that it was late summer 2015, and there wasn't any production for 2 years basically, or any mining, and it was really seen that next winter, if it's cold, probably the heaps will freeze, and then all the water will release, and that's a then huge catastrophe. And it was seen that the best way is to put the process running again. And basically the only way to do that in that kind of a situation is to put government money into it.
Right. So, oh yeah, you can see.
Hello, Kalev Kalemes from Ministry of Economic Affairs from Estonia. I had a small part in inviting you here, but can you tell, after Trafigura has purchased some shares, or the government has decided to sell some shares, do you see further that further shares will be diluted to private sector, sold to the private sector, or the current setup with 15% private ownership or 16% private ownership will continue for foreseeable future?
of course, the lifetime of the mine is so long that we don't know what happens in the long term. But of course, we have more than 84% of the shares, and I'm not taking part of those negotiations, but for sure there are discussions to include also other parties, but we'll see what happens. But most likely for some time the operations, we will be the main owners of the operating company.
So thank you once again, Jani, and enjoy everything what is going on further.
Language was, yeah.
Yeah, but I guess people are able to communicate with you in several languages, and even I will be able after 5th beer to speak in Finnish, so no problem.
Hyvä.
Thank you.
Kiitos.